All right, good evening. It's 8 o'clock, so we'll go ahead and get started. This Zoom session should actually go fairly quickly. There's only really one new major thing that we're talking about this week, and it's about creating methods and calling methods. Calling methods we've actually been doing the entire time. Things like when we call the println function, whenever we want to print something to the console, that's actually calling another function, a Java function that does some work for us. So we've called some functions, and there's a print one. Whenever you create a scanner and you do scanner dot next int, that's calling a function that does some work for you and gives you some output in return. So we have been calling functions throughout the whole course so far. But today we'll start looking at creating our own functions. And you'll hear me use the word functions and methods kind of interchangeably. They really mean about the same thing. Java usually likes to use the word methods, and languages like C and C++ like to use the word functions. I think Python likes to use the word functions, but they're almost pretty much interchangeably. So if you hear me say the word functions or you hear me say the word methods, they really refer to the same thing in the context of this course. So we will see how to create our own methods, why we want to do that, what the use case for them is. We'll show you how to do it, and then we'll kind of go over a few examples of where it might be useful to create our own methods. Okay, so first of all, what is a method? Well, you can think about it a little bit like a black box. And what I mean by black box is, imagine you have this device, or exactly like it sounds, a black box. You can't see anything inside of the black box. All you know is you can give this black box some inputs, and in return, it will give you some kind of output. Now, you don't know how it does that, how it does the work. How it does that is not important. What's important to you is what inputs you give it and what outputs it gives you in return. That's what a black box is where you cannot see the inner functioning of how all that happens, but really it's unimportant to you. Like I said, all you need to know is what are the inputs and what are the outputs that you expect to receive. So like a real world physical device that you could think of that's like a black box is a TV, right? You don't know how the inner workings of a TV actually do their thing to show you something and to play sound. Maybe if you're an electrical engineer or TV repairman, or some kind of engineer working at a TV production facility, maybe then. But certainly the average person has no idea how the internal workings of a TV, figure out what to display on the screen and what sound to produce, right? So you can think of that TV like a black box. So what are the inputs to the TV? Well, the inputs to the TV are, the channel that you want to put it on. That is the input that you provide to the TV. You provide the channel you want the TV to be connected to. Another input to the TV, if it's a smart TV, you connect it up to your Wi-Fi, right? The Wi-Fi is another input into that TV black box. Or, if you're using over-the-air signal, maybe you hook an antenna up to your TV. That is another input. So you can kind of look at, these various ways of providing input to the TV. You can change the channel. You can set the channel whatever you want. Maybe it's connected to your Wi-Fi, so it has Wi-Fi input. And if it's connected to an antenna, you have antenna input. So what are the outputs from this TV black box? Well, the outputs from the TV black box are the display screen. What picture is it displaying to you, right? What video is it playing to you? And what sound is it making? Those are the outputs. So we have this set of inputs, which is I set what channel I want it to be on, and I connect it to my Wi-Fi. That's the input I'm providing. The output it provides back to me is it shows something on my screen and it plays sound. And those things are going to be related, meaning whatever channel I set it on, the TV is going to do some kind of magic inside this black box to display to me the video associated with that channel and the sound associated with that channel, right? But as I said, we don't know how the inside of the TV actually works. But we don't but to be a user of that TV, we don't need to know how the internal of the TV works. So that's what a black box is. You have inputs. Inside the black box, something happens, you don't know what, and it's not important to you. And then you have outputs, which is what does it do for you? Does it give you some value? Does it show you something? What are the outputs? Okay. So you can think of methods as black boxes. So let's look at one of the simplest methods, and one we've been using all course long is the print function. It's called system.out.println, right? And inside here, we tell it what we want it to print, right? So this is actually a function. The name of the function is actually println. That's the name of the function. But we access it like this, and that's just because it's in some other modules associated with the program. It's not directly in the program that you're writing yourself. It's located somewhere else in Java. It's provided by Java, actually. But this is the name of the function that we want to execute, okay? So we can think of this println as the black box. So what are the inputs to this black box? Well, the inputs are these parameters here. This is my input into that method. And so what does this mean, right? What will happen here? Well, I know because maybe someone else has told me, or I've read the documentation for it, that whenever I call this method, the println method, whatever input I give it, it will display on my screen, right? It'll display in my console whenever I run the program. So this is my input. The input is this string called hello world. This is the black box, the println. That's the black box. I have no idea how the internals of println works. And what are the outputs it gives me? The output is it writes that to my screen, right? And so, like I said, this is exactly like a black box because we don't know how println takes this string and does a whole bunch of things to eventually get it displayed on our screen. I mean, you can imagine all the steps it has to go through. Well, first it has to take the string and it probably gives it to the operating system. Then the operating system gives it to that console output. Then it gets sent to your graphics card. Then it gets sent as electrons over your your HDMI cable to your monitor. Then your monitor takes that and converts it into individual little pixels on your screen that happen to spell out hello world, right? There's there's a lot of different steps in there, but ultimately you, the programmer, you don't care about all those intermediate steps. All you know is you have this black box called println. You give it some kind of output. You give it an input, which is what you want it to print, and the output you receive in return is it gets displayed to your screen, right? So let's run this, and this will do exactly what we expect it to do. This is nothing new so far, but the explanation is new, right? So we run it, it's compiling, there we go, and it printed out hello world to my screen. So all those intermediate steps where this hello world went to the operating system sent it to the graphics card, et cetera, et cetera, et cetera. All those steps actually did have to happen for this to show up on my screen. But that's what, not just println itself probably used a lot of black boxes to get there. But from our level that we're looking at, all we know is some magic happens inside of here that takes our input, does something with it, and eventually gives us some output in return. And in the case of println, the output is it just prints to our screen. Okay, so that's how we can look at functions as black boxes. Not too different from a scanner. Let's look at the example with a scanner. Let's make a new scanner from the input, right, from the keyboard. And let's tell ourselves to, enter your name, right? Enter your name. And then here, we're going to get the name. String name is equal to the scanner.next, right? That'll give us whatever they type in. And then we're going to print that out. ln, your name is name, right? There we go. There's a complete little program. And what does our program do? We make a scanner to read from the keyboard. We give them a prompt. We're going to say, hey, enter your name. Then we're going to get the name that they typed in. This gets the name from the input. And then we're just going to print out, your name is whatever you typed in. Let's run it. And then we're going to kind of go step by step to see, how all these different functions are working. So let's run it. Here we go. There we go. Enter your name. Name is Dan. Press enter. It says your name is Dan, and the program completes. All of this right here is not new, but a little bit of the explanation of what we're doing is new. Okay, so like I said, make a new scanner. Here we're using the method called print. Almost identical to the println that I just described. The only difference here is print does not put a new line at the end of it. It does not return to the next line, but println does. Minor difference in detail, but that's why they are different methods. So again, we have this black box called print. I'm giving it this as the input. And what is the output that print gives me? Well, print gives me this output. It printed this to my screen. So this print is the method, right? That's the input, and that's the output, okay? Now look here. Now we're going to do this name is equal to the scanner.next. We've seen over the past few weeks how to get input from the user from the keyboard. And we know that this scanner.next method, if I hover over it, my IDE is smart enough to give me some information on what this method is. But we already know, because we've done it several times in this class over the past few weeks, that this gives us the next string that the user types in at the keyboard, right? But this is a method, right? The input is actually nothing. The input you give to your method will be inside of these two parentheses. This is the input. For next, there is nothing inside the parentheses, and so we're actually not giving it any input, which that's fine. You don't have to give a method input, just like you don't have to give a black box input. But we have this method next, but there is no input to it, and that's fine. But what does it give us in return? What is the output from this method? The output is it gives us back the string that we typed in, right? So that's why we say the string and name is just the name of my variable. It's going to be equal to the output from this method. And the output from the next method is just the next thing they type into the keyboard. So that's how this next is a method that, again, acts like a black box. Do we know all the internals about how this next method works? No. Just like with the print, I said it gives the string to the operating system. The operating system gives it to your GPU. Your GPU sends it over the cable to your monitor. Your monitor takes the electrons and converts it back into pixels on your screen, et cetera, et cetera, et cetera. But you don't need to know that level of detail for the print. Likewise, you don't need to know that level of detail for the next method. All you need to know for this specific method is what is the input, and for next, there is no input. It doesn't need anything from us. But what is the output? Well, the output is the string they actually typed in on the keyboard, right? And that's why we set the variable equal to it. Okay. And then we'll look at the last method we're calling. The last method we're calling is, again, the println, almost the same as print. It just, this one has a return at the end of it, right? But the same concept remains the same. The println is also a black box. What is the input to that method? This is the input. Everything inside of those two parentheses is the input to that method. And what is the output from the method? The output is, it displays it on your screen. That is the output. So that's how we've already been calling functions and using methods. Again, functions and methods mean the same thing. I do a lot of different programming languages, and so I use the two terms interchangeably. But this is how we have called Java methods throughout the whole course so far, right? You call the method by you putting its name, you put parentheses, inside the parentheses you put the input, and how you get the output is kind of dependent on what the method does. For the print, we know it just displays to the screen, right? It displayed that and it displayed that. For the scanner.next, we know the input gives back to us the string they typed in. So to get that string, we got to have a variable equal to it. Again, this isn't new code that you haven't done yet, but it is a new explanation of kind of how it works. This is a method that already exists in Java. Someone else actually created it, but you're using it by calling it by its name, and its name is next, and it's associated with the scanner that we created right here. Okay, so that's kind of how we call a method. And again, these are a few very simple examples. We will do some more examples of our own. That's how we call a method. Okay, that's all good. We're calling this print method, and this already exists in Java. We're calling this scanner next method. That's great. That already exists in Java. We're calling this println method, and that's great. That already exists in Java. But what about creating our own methods? Well, we can create our own. And here's how we do that. Let's imagine we want to make a program that computes the area of a circle. Okay, so let's make a very simple program to compute the area of a circle. Okay, so we still have the scanner. Let's say we want the user to type in, what's the radius? The area of circle is equal to pi times the radius squared, right? That's the formula for the area of a circle. So let's make a program that computes that for us. Okay, so we'll still make a scanner. Instead of enter your name, we're going to say enter the radius. Let the user type in what the radius is they want to compute with. Okay, so instead of getting a string, we now need to get the next, let's say the next float. It could also be a double. A double would work here too. I usually like working with floats. That's just what I do, mostly from graphics programming type stuff. Let's say this is the radius, right? And then let's compute the area. The area will be pi, which we know pi is 3.1415927, and some other stuff, times the radius, right? That's the area of a circle. And now let's print it out. The area is area. All right. Yep. So that's a very simple program to compute the area of a circle. So we'll make a scanner to read from the keyboard. We will use the print method to print out, a little prompt, hey, enter the radius. We'll use the next float method. It works almost identical to the next method we just described, except the input to this method is still nothing. It doesn't need anything from us, but the output from this method is the float number that they typed in. So that's why we're saving it by saying this variable is equal to whatever the output is. Here, we're just doing some math to compute the area. And then here, we're using the println method. Again, that black box, we're giving it, this is the input. And the output from this method will be, it'll display it on our screen. So let's run this, and then we'll see how we can kind of create our own method to kind of replicate some of this work. So let's run it. There we go. Enter the radius. Let's say, just say the radius is 1. The area is that. Let's run it again. Area is 2.3. Excuse me, the radius is 2.3, and that computes the area. Okay. So we have a little program that computes the area of a circle. Okay. Well, instead of getting it from the user, let's just say we have a bunch of circles we want to compute the area. So say float area is equal to 3.14159, cut it off there, times 1 times 1. That's a radius of 1. Let's print that out. Let's just say we're doing some kind of math computation for whatever reason. Is area. But let's say we have a bunch of these. We're just going to do this calculation a bunch of times. Area. So first we'll do it with 1, then we'll do it with 2, then 3, then 4, and then 5. Okay. This is still not creating our own method, but I'm showing you kind of how we can go from some repetitive code, which this is repetitive, and to make it function out. So let's run it. There you go. It computes all these areas and displays it to us. Okay. But what we see here is a bunch of repetitive code, right? These lines of code are almost identical to this. The only difference is, this uses 1 and this uses 2. It's almost identical to this. It's almost identical to this. They're all almost identical to each other, with the exception of, this number is using really as the radius that's using for the circle, right? So whenever you're seeing code like this that is kind of repeated or almost identical, then it's really a good use case for a function. So let's create our own function that kind of replicates this, and then we'll see how to call our function to get all this same work done with a little bit less typing, a little bit less code. Okay, so here is how we create our own function. So we need to start a new code block. So you can see here, the main function, which is what this is, that's the start of it, and that's the end of the main function. So this needs to go outside of the main function. Still inside of our class, see our class starts there and ends here. So it'll be inside of the class, but outside of our main function. You can't create a function inside of another function. You can't do that. So we have to create it outside of our main, but still inside of our class. Okay, the first thing you want to do here is you want to decide, is it going to be public or is it going to be private? Now, there is another one that is called protected. We're not going to really touch on that one yet. That's for probably your next level Java class. It's not going to be covered in this Java 141 class. So the ones we'll worry about is public and private. So what do those mean? Public means it can be accessed from some code outside of this class. And what do I mean by that? When I look at this class main, again, it starts here and ends here, right? So if I make a function public, as in this main is public, that means this function can be called and it can be accessed outside of this class. If it is private, it cannot be accessed outside of this class. So this is kind of a way that you can protect a function, a method from being called outside of the class that you're creating. You get to decide whether only you can access it inside this class, or if other people can access it outside of this class. You get to decide that. So for example, I'm going to make it private. That means only code inside of main can access this method. Okay. The next thing you have to specify is static. This is a little bit of a tricky one because we haven't talked about objects yet. But just for the current methods that you're creating, they will all be static. And to briefly summarize it, it just means that this function, excuse me, this method is not directly tied to an instance of this class. Now, I know the words instance and those type things is probably not immediately recognizable to you, and that's fine because we haven't got to that point in the class yet. That's actually in the final week when we'll start talking about different Java objects. So for the methods that you're creating so far, and we will look at possibly changing that in week 8, but they will be static. That just means I don't have to create an actual class main to use it. Again, that explanation will probably make a lot more sense once we get to week 8, but just know that you need to use static here. And you can see that our main does use that static. Okay. The next thing you put is what does it return? Now, that doesn't mean what does it display on my screen. That's completely different. We need to think about what it returns. Well, whenever we looked earlier, yeah, let's do that. When we looked earlier, when we made the scanner, what is it? System.in, right? We made the scanner. Whenever we do, scanner, let's say S, next float, right? So next float, we got to think about what does it return. Luckily, my ID is pretty good, and if I hover over it, it kind of tells me a lot of useful stuff, and I like that. But here's what the next float looks like, and you can see here it has float. That means it gives back to me a floating point number. That's why I have this float is equal to this method, because the method returns to me a float. If I use next double here, I have to make this a double because this next double returns to me a double. Likewise, if I use just next, I have to make it a string. Why? Because next returns to me a string. So this is what it gives back to you. So if we want to make something that computes the area of a circle, maybe we want it to return a float. What's the area? I promise this will start to make more sense once we get it all filled out. Now, the next thing you have is what is the name of your function? And you can name the function almost anything you like. It still has to follow the naming conventions the same as variables, meaning it can only contain uppercase letters, lowercase letters, and numbers. It can't contain symbols. It can contain some special characters like underscores and things like that. Actually, underscore might be the only special character that it contains, I think, as far as a variable name goes. But like I said, the name of the function follows the same naming conventions of a variable. So uppercase letters, lowercase letters, and numbers are really what you want to stick with. But it can't start with a number, meaning I can't name it that. That's not going to work. I have to start with at least one letter, and that's fine. The letter can be uppercase or lowercase, that's fine. It just cannot start with a number for the name of it. But that's the same naming convention that you have to use for your variables. All right, so let's name it. You want to name it something that is descriptive of what it does. All right, so for example, the method println, that is descriptive of what it does. It tells you it prints, and the ln actually stands for new line. Yeah, the letters are backwards. I don't know why, it just is. But it's descriptive of what it does, right? It prints something, okay? So let's name this something descriptive of what it does. It's going to compute the area of a circle, right? So we'll call it compute area of circle. We can call it that. Now we give it some parentheses. In parentheses, we have to describe what is the input that we need for our function. What is the, like I said, when we were talking about the black box earlier, for this black box, this is the input, right? What is our input for computing the area of a circle? Well, we know that the area of a circle is equal to pi times the radius, right? So what do we need to know in order to compute the area of a circle? What information does it need in order to do its job? Well, it needs to know what the radius is. Sure, it also needs to know what pi is, but since pi is a constant number, we don't have to explicitly tell it what pi is, because pi is a specific number, right? But it does need to know what the radius is, because the radius could be anything, right? The radius could be 1, the radius could be 1 million, right? So we need to, as input, it needs to know what the radius is. So we'll say float radius. This means our function expects the user to give it a floating point number, and that floating point number is the radius of the circle. And then we have to finish the function. Well, it's not finished yet, but to designate the start and end of the method, we use the curly braces. Just like we have here for our main starts here, our main ends here. Our method compute area of a circle starts right here and ends right here. Okay. So now inside of here, here's where we do the actual work. So let's compute the area. So the area is equal to pi. Let's just abbreviate pi times the radius, right? So we've computed the area. What else do we want to do? Well, we're trying to kind of replicate all of this work, right? Trying to replicate all this work. So we could do this. We could just go ahead and print it out as well. We'll show you a couple different ways to do it. So we could do that. Let's just do it like that the first time, and then I'll show you probably a little bit better way. And for the example this way, let's change this to void, and I'll tell you what it means. So we'll do one this way, and we'll do one the way I actually prefer. Let's make this a float. Compute area of a circle 2. All right. Because you can't have two functions with the same name. So this compute area of a circle, compute area of a circle 2. Just something with different names. And here, let me put in the code, and then we will describe it. Okay. So here with this function, again, this is the name of it. This is what it returns. When I say void, it means it doesn't return anything. That's what void means. It just means nothing. It doesn't return anything. Now, it is doing something, right? It is computing the area. It is printing it to our screen. So that's the work it's doing, but it doesn't actually return anything at all, like we see here. And we'll describe this one in a minute. It doesn't return anything. Okay. For our compute area of circle 2, it does return a float. That's what the float here means. It means it returns a float. It is computing something and giving us a float in return. It is also computing the area, but instead of printing it, it's going to return it. Now, how do we make use of these two functions we created? So these are two functions, right? Private, static. Void means it doesn't return anything. Compute area circle is the name. This is the input to the function. And this is what the function is doing. This is kind of like the black box part to it. Although it's not so much of a black box to us because we are the one creating it. But whenever you use the function, and we'll use it here shortly from our main, whenever you're using the function and calling the function, you don't care about the internal workings of it anymore. And we'll see that here shortly. Okay, so that's this one. Compute area circle, computes the area and just prints it out, does not return anything. Compute area circle 2, computes the area and returns the area, which is a float. All right, so let's see how we can use it. So I'm going to leave all of this code here, but I'm going to comment it out just so we can see, how we started and how we finish. So there's that. So now let's do all this same work, but we will use this function instead. So what can we do? We can call compute area circle 1, 2, 3, 4, 5. Let's change those to 2, 3, 4, 5. Oh, if I could use my numbers correctly. There we go. Okay. So this code right here, let's see if I can shrink it down slightly. Now, all right. So at first we had all of this code, and actually let's not put the spaces in here so we can compare apples to apples. So how many lines is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 lines of very repetitive code. Now it's just down to 5 lines. And you could say, yeah, well, what don't we count the lines from here? Let's say we also count the lines from there, and we're still only up to 9 lines of code. But the thing is, as we add more and more of these, the savings on how many lines of code we write greatly increase. All right, let's take it out for right now. So where we originally had this code where we're in main computing the area and printing it out, here we're just going to call a function. This is the input to the function. The output is, whatever we programmed it to do. The output is it's going to display this to the screen. Now, it does not return anything. We will see the difference between these whenever I start calling this one. Okay, let's run it and you'll see we get the same thing. This was the previous code. And now when we run it, we actually get the same answer. Okay. So that is how you make your own method to do something. And it can do whatever you want it to do. For this, we're just computing the area of a circle. Okay. So let's look at the kind of the difference between these. Again, they both take this as input. The output from this is it displays it to your screen, but it does not return anything. And this one does not display to your screen, but returns the area. So let's see the difference between these two. So now let's do compute area of a circle 2, put the radius of 1. Let's make 5 of these. think that's 5 of them. There we go. Let's put a little, just a printout in here so we know when one stops and one begins, or one ends and one begins. So what'll happen here, it'll do all these functions which print to the screen, right? Then it'll print these dashes so we can see the separation between all of these function calls. Let's run it. You can see here, we're only really getting the first half of things, right? We're getting those printed out. This is what's printed out. Then we get the dashes, but then we don't get any more printout. It shouldn't come as a surprise, because when we're using compute area of a circle 2, this is the function. There is no printout here. It's just computing it and returning it. So we, just like when we had, the scanner, the float equals the scanner.next float, we need to do something similar here, because compute area circle returns a float. It gives us back a value, and that value is the area computed. So we could do it like this. I'll show you a couple ways. Area is equal to that. And then we can print it out. Let me do some copy and pasting here to make things easier for me. So we'll do it with 1, 2, 3, 4, 5. Now let's run it. And you'll see we'll get the same thing, and then we'll talk about it for a second. And there you go. Almost the same thing. In here, I used the word area is. And here, I didn't put the word area is. I could have. But you see, you get the same answer, right? So what happened here is I made my own function. It returns a float. This is the name of it. This is the input. This is what it does. You can think of this as like the black box. This is what it does. It returns the area. So this variable area is equal to whatever it returns. And then I'm printing it out. We can compact that a little bit further, like this. I can make it a little bit shorter. Three, 4, 5. Let's run it. I'll show you it's the same thing, and I'll show you why it works. There you go. Still get it printed out. And that's because we are using this function println, but inside of here is another function, right? So you kind of work from the inside out. This is the innermost function. It's the one we created, this compute area of a circle 2. This is the input. And what does it return? It returns to us a float, right? So you can think of this whole thing as being just a single float number. It's equal to whatever it returns. Since it returns a float, this println is just going to print that float that it ends up computing. Okay? So that's 2 examples of making our own functions. One does not return anything. It does, display something to our screen, but it does not return anything to us. That's why we don't do anything like this. And actually, if we try to do that, my IDE actually complains to me, because it's saying that the function returns void, which means it doesn't return anything. But I'm trying to say, this float equals to it. But that doesn't work, because it doesn't return anything. Void. But it does work for this one. And kind of really the reason I showed you these 2 examples is I highly prefer this one. And, in an actual programming environment where you work from a company or something, you'll probably want to do this one. You generally don't want to have input or output, meaning like keyboard input or printing to your screen inside of functions, unless that is specifically the purpose of the function. Meaning, whenever we compute the area of a circle, setting aside programming languages for a second, when you think about computing the area of a circle, logically, you're just computing a number, right? If you're just thinking about, what is the area of, with radius 2, okay? When you're logically thinking about that, you're not also thinking about displaying it to a screen. That's kind of a separate problem, right? When you have a function to compute the area of a circle, you really should just be computing the area of the circle and returning what that answer is. Printing it out is something different. That's not computing the area of a circle. That's computing the area of a circle and displaying it. If that's what you want your function to do, that's okay. But then maybe you should call this something different. Maybe it should be compute area of a circle and display to my screen, or something like that. But if your function is just supposed to compute the area of a circle, you probably shouldn't have any kind of keyboard input or display to your screen going on, which is why I highly prefer kind of this method. And then in main, whenever you get that value back, meaning this, now here, you can do whatever you want with that value. You can display it. Maybe you put it into a database. Maybe you use some kind of microcontroller to control something. I don't know. There's a million different things you can do with this value. But then it lets you decide back in your main what you want to do with that value. And for us, we're still printing it, but it gives you more control over what you actually do with it. So I highly encourage you to not do keyboard input or displaying to your screen inside of these functions you create, unless that's specifically what you want to use it for. And let me do an example of that, and then we'll start wrapping it up about making our own functions. Okay, let's get rid of actually all of this stuff. We'll just have our main here. And we'll make an example that actually relates directly to some of your previous assignments. Okay, so in one of your previous assignments, you were getting some input, and you had to make sure that that number was between 100 and 200, right? You were getting input from the keyboard, and you had to make sure it was in a certain range, and also that it was a multiple of 5, right? You had to make sure that number was a correct number. Okay, so let's make a function that does exactly that for us. And since it is explicitly the purpose of the function to get that input, at that point it's okay to use input and display from your function. So let's make a function, private static. The return is going to be an integer. It's going to return what the number they actually typed in. Okay, and let's name it get number from, actually let's call it integer, get int from keyboard. Okay, so how do we do that? Well, just like we would in main, let's make a scanner. Scanner system.in. Oops. Okay, we need to get the number. The number is what the scanner.nextInt, and then we will return that number. Okay, so we'll get more specific with this with the ranges and stuff. But now here in our main, we can just say num1 is equal to get int from keyboard. Num2 is get int from keyboard, and num3 was get int from keyboard. We'll make this successfully more complicated. And then let's just say you want to add them together for whatever reason. Sum is num1 plus num2 plus num3. And then we'll just print that out, whatever the sum is. All right, simple little program, but instead of directly getting the input here in our main, we're just going to use this function to do the input work for us. Okay, like I said, we'll make this more complicated in a second to kind of match when I think two assignments ago when you had to check the range of a number. But right now, we're just going to get the input from the keyboard, and as long as it's an integer, we don't care about ranges yet. Let's run it. Here we go. It's waiting for the first number. The first number is 1, second number is 2, third number is 3, and the sum is 6. So that's right. So this get input from the keyboard, the first thing it does was get the number 1 I typed in. It returns that 1. So num1 is equal to the value 1 because that's what I typed in. Num2 is the value 2. That's what I typed in. Num3 is the value 3. That's what I typed in. It adds them up and prints it out. Okay, let's make this a little bit more complicated. Let's say we want it to be within a certain range. So what does this function need to know to make sure it's in the range? It needs to know the minimum number it can be, and it needs to know the maximum number it can be. Okay, so when we enter the number, we need to make sure it's within the min and max. So let's say if the number is greater than or equal to the min, and the number is less than or equal to the max, then we can return the number. Let's forget about this for a second. But if this is the case, then the number is in the correct range, right? So what happens if number is not in the correct range? If it's not, it goes down here. So actually, we need to make a loop here that keeps having them enter the number until it's in the right range, right? We've done loops in the previous classes. So if you have a question about these loops, let me know. Let's have a do. No, let's just make it a while true. Like this right here. So making our scanner, we're going to loop while true. That just means loop forever or until I return. Okay, so we're going to get the number from the keyboard. If the number is in the correct range, then we're going to return the number. If it is not, then we're at the end of the loop, so we'll just go back to the top of the loop, and I'll have to type it in again. So let's add some prompts to the user so they know what's going on. So here we'll say, print ln, enter a number between the min and the max, right? And here we'll say if they got here, we'll say it's an invalid number, right? Print invalid number, try again. So let's look at how this works. So for our function, it's going to take as input the min range and the max range, creates a scanner. It's going to say, hey, enter a number between this min and this max. Actually, let's make it all on that one line. Plus, make it look like an actual prompt that they can type something into. And I meant to put that inside of here. There we go. So we'll make a scanner. We're going to do a while loop. And the while true just means it goes on forever or until I return. Once I return, it stops the loop. And that's what we want. So inside the loop, hey, enter a number between the min and max. We're going to get that number from the keyboard. We're going to check if it's in the range. If it's in the range, we're going to return it. If it's not in the range, it goes here and just says invalid number, try again. Okay, so let's look at how we can use this. So now you see the red squiggly lines here, and that's because our function now expects some input. it expects you to give it the min and the max range. Let's say the min is 100, max is 200. Okay, let's change it up a little bit, just so you can see that it relies on these values that you send it, 3 and 4. So now let's run it. So now we go, enter a number between 100 and 200. And that's because I'm calling my function with the range of 100 to 200. So now if I put something not in the range, invalid number, try again. So, it got right here in the number. I typed in a 1. It was not in the correct range. So I go here, invalid number, try again. We're at the end of the loop. So I go back to the top of the loop and do it again. All right, so let's put something in range, 111. Okay. Now enter a number between 2 and 300 because I'm calling my function with 200 as the minimum, 300 as the maximum. Again, you see if we put it too low, try again. If we put it too high, try again. So let's put 222. That's in range. Now do it between 3 and 400. 333. There we go. It adds them all up, and unfortunately, that's 666. So we've expanded upon our function to do all these different things. And you can see how it's reduced the amount of code that you have to type in. Because previously, in your earlier assignment, you may have had this entire thing and repeated it for each number you wanted to input. Here, we've made this code to check it just one time, and every time we call it, it uses that same code, that same check. That's kind of the power of a function, is you write the code one time, and then you utilize it multiple times. So if you want to go back and look at your previous assignments, or you want to use it for your assignments going forward, here is a really good way to get input from the keyboard and making sure it's valid input, but making it a lot simpler instead of replicating this multiple times for each time you want to get input. You kind of centralize it in one place, and then you call it multiple times for each number you want to get. One small example among many examples of using functions. Functions can do whatever work that you can possibly program into them. Anything you can imagine. You can imagine, instead of get input from keyboard, maybe it is get int from internet. I don't know. Maybe as an input, we give it the URL. And so maybe inside of here, we do a bunch of code that, goes to visits some website, reads a number from the website, and then returns that number. Crazy example, but it's an example of different things you can do in a function. It doesn't just have to be, one specific little thing. Anything you can imagine can go on in here. Instead of get int from internet, maybe we have get int from database. And so for that, maybe we have to say what table that number is in, right? So you can do any kind of work you want inside of these functions and then call it from your main just like this. Right. So that is just a couple examples of making your own functions. Again, I'll talk about what each part of it is, and then we'll wrap it up and answer any questions you may have. So first, we have either public or private. Public just means it can be accessed outside of your main, meaning if you have other Java files, you will be able to use that function. Private means you cannot access it outside of the main class. You cannot access it in other files. So it just depends on how accessible you want that function to be. Static just means it is not tied to any specific instance. That terminology will become much clearer once we get to objects in week 8, the last week. But for now, you can consider all the methods that you create to be static. Then we have what it returns. Void means it does not return anything. You can notice here at the end of main, there is no return like there is here. We return number. In main, there is no return because it returns void, which means it returns nothing. So there is no expectation of anything being returned. But for a get input from keyboard, it returns an integer. So at some point in here, we need to return an integer value. And right there is where we do it. This is where we return an integer. When we return something, we have a variable equal to whatever that return is. Get int from keyboard is the name of the function. The name of it follows the same naming conventions as variables. It can be uppercase letters, it can be lowercase letters, it can be an underscore, and it can be numbers. But it cannot start with a number. It can start with the other ones. It can start with uppercase, lowercase, or an underscore, but it can't start with a number. But it can contain a number. It just can't start with a number. Inside here is the input that your function needs in order to do its job. For the get input from keyboard, it needs, what the minimum and maximum ranges are. If there's anything else that you want that it needs to know, you can add it on here. But for example, the only thing it needs to know is what is the minimum and maximum range. So I'm specifying what is my input. The curly brace starts the function. This curly brace ends the function. So inside of here is all the code that executes when that function is called. For example, we just create a scanner, make a while loop, and we're getting this input from the user, making sure it's in range. If it's in range, we return the number. We return the integer. Okay, so that's why we have this variable is equal to the function, because it returns an integer to us. All right, that is how you create your own function with an example of how we do it. Okay, that is all we have to cover for this week. What are your questions?
Hey, Professor Stuffy.
Yep, go ahead.
I've seen it both ways, where they have some people put the methods above the main and some people put it below the main. Is there a preference there for any reason?
No, and Java doesn't care if you put one before the other. It doesn't. In other programming languages, it does matter, but Java does not care. And so whenever I'm looking at your assignments, it does not matter to me if you put them before or after. If you go on in the future and work for some kind of company and doing programming or something, they'll probably specify to you which they prefer for whatever style they have. But for this course and for Java itself, it doesn't matter if you put them first or last.
And one more question about the modifiers in the methods. When I've seen it too in some of the examples and stuff, that where the private or public is left off entirely. And is there a default there if it's left off, or is it what happens then?
Yep. If this is left off, it defaults to private. I highly recommend you explicitly put private. It makes it better for readability that if you explicitly put it there. But if you leave it off, it does default to private. But I just think I think it's much more readable. It's much more legible, I guess, for the next person who has to look at the code. If you make a method and 2 years later someone else follows you and has to read your code, I think it makes it much more explicit, which I think is a good thing. But if you leave it off, it will default to private. All right. I'll wait about 30 more seconds for any other questions before we wrap it up. So standing by about 30 more seconds. All right, we'll go ahead and wrap it up. Video was recorded, so I will get it up on the course site here a little bit later this evening. I am back from my travel, so I will be finished grading week 5's material today and tomorrow. You should have your grades for that tomorrow. And if you have any questions about any of the material or need help with assignments, just please let me know. Other than that, have a great evening.
Thank you. Bye.